there's one tool that I've come to find invaluable for manually focusing. That is the follow focus. Originally intended for cinema applications, it rotates your focus control so that the focus dial turns in effectively the same direction as your focus moves, instead of course, wrapping around the lens, which, as a result, this eliminates the mental gymnastics needed to remember which way you need to turn the focus ring to make the lens focus in the direction you want it to go. What's up everybody, I'm Jason and welcome back to the channel. While follow focuses are incredibly useful and have a long history around their use in design, today, especially for those of us who are not using cinema lenses, cinema cameras, or shooting in a cinema situation, using one may seem a bit weird. More importantly, when pairing it with an autofocus, or especially an electronically focused autofocus lens, exploiting all of its capabilities effectively has become somewhat more difficult. So this time around, I want to take a look at follow focuses and using them with the variety of lenses that you will likely be using them with on a modern hybrid mirrorless camera. But to start with, let's take a quick look at a fairly typical follow focus and its features so you know what these are. Now, the biggest feature of the follow focus is how it reorients the focus controls in a way that doesn't require mental gymnastics to understand what's going on. By rotating the controls, the direction the control rotates in and the direction of your focus movements can be the same, or at least similar. With a follow focus, when it's used on a standard left-hand rule lens, that is like, for example, Canon lenses or almost all cinema lenses, the bottom of the focus wheel will travel in the same direction as your focus is moving. For right-hand rule lenses, those will typically be Nikon lenses, it will be the top that moves in the direction of focus instead. In other words, what I'm saying here is that if you turn the wheel like this, it means that you're focusing towards infinity, and if you turn it this way, then the camera will focus towards you. Now, another useful feature is that a follow focus gears down your focus controls relative to turning the ring on the lens. Now, the exact ratio will vary from lens to lens based on the lens's diameter and the gears on your focusing ring, or your follow focus rig, I should say. Now, if you're interested, you can calculate this ratio by comparing the number of teeth on the follow focus to the number of teeth on your lens's focusing gear. Now, if you don't want to sit there and count them all, you can figure this out by simply taking how many teeth are on your lens gear, or you can figure out how many teeth are on your lens gear by measuring the outer diameter of that gear, dividing it by 0.8, which is the modulus of all cinema lens gears, and subtracting 2. So, for example, this gear on my RF24 to 70mm f2.8 is 96.8 millimeters in diameter. If I divide that by the cinema gear ratio modulus of 0.8, I get about 121. Subtract 2 from that, I get 119. Now, since I know my follow focus has 43 teeth on its gear, because it's written on it, that results in a ratio of 2.76 to 1, or put another way, I will need to turn my follow focus 2.76 complete revolutions, or 2.76 times, to get the lens's focus ring to turn once. Now, as you can imagine, this can help increase precision when focusing with a lot of lenses, especially ones that are very short focus throw. That said, with electronic focusing lenses that we have these days, this gets even more complicated, and we'll talk about the details of that in a bit. Now, additionally, many follow focuses will provide several features to aid you in pulling focus. On this follow focus, which by the way is an inexpensive small rig one, we find 3 additional features. First is the white ring. Now, this can be marked up with dry erase markers to indicate which focus positions correspond to which actor's marks. Additionally, on some of the higher-end units out there, these glow in the dark, or can be made to glow in the dark, to aid in working on a set in the dark without needing to have a light. Unfortunately, this one doesn't have that feature. Fortunately, I've never needed it yet. An additional feature in the dial is this square hole in the middle. This can be used to attach either a crank handle or a whip, neither of which I actually have at the moment. Now, the handle makes pulling some focus moves easier because, well, first of all, it gives you a bigger thing to hang on to, and it's a crank. Similarly, the whip is essentially just the knob on the end of the follow focus, but it is on the end of a flexible shaft. This isolates the camera and lens from you so that when you're making focus adjustments, it doesn't cause the camera to shake, or at least shake as much. Now, the final feature found on this follow focus, or on many follow focuses, I should say, are positionable hard rotation stops. Now, of course, while all manual focus lenses have hard stops at their maximum and minimum focus positions, well, technically all lenses do, if you are continuously moving between two intermediate positions, it can be incredibly useful to have hard stops there instead. And that's what these are there to provide. So with the tour of the follow focus out of the way, let's talk about how it works with the various lens types out there. Now for this, I'm going to break lenses down into three categories based on how the focus ring and focusing elements are coupled. These are directly coupled, semi-directly coupled, and electronically coupled. Now, before I go into the details on these, if you were just using the follow focus as a more convenient focusing ring, and you aren't trying to use the hard stops or the focus position marks or anything like that, then most of the stuff that I'm going to cover here, you don't have to worry about. You can just put your follow focus on your rig and go start focusing. So with that said, let's start talking about lenses. And let's start by talking about what I am calling directly coupled lenses. So these include all manual focus lenses, whether they are designed for cinema or still use, as well as any autofocus lens where the focus ring rotates when the autofocus system is active. In other words, there is a complete and direct mechanical connection between the focus ring and the focusing elements in the lens. Now, these kinds of lenses are what follow focuses were originally designed to use or be used with, and are the most straightforward to use. With these lenses, the follow focus just becomes the new focus control. You don't have to worry about losing sync between your marks on the follow focus and the lens itself, since there is nothing that can interfere with that situation. Well, I say nothing, but there is only one real concern that you could potentially run into with these lenses, and that is if, like me, you're using add-on focus gears. In that case, it is possible for those gears to slip if they are not tight enough, so just make sure they're tight enough. Now, the next type of lens from directly coupled are semi-directly coupled lenses. These are autofocus lenses. They have almost always been for SLRs that have full-time manual focus capabilities, but the focus ring does not rotate when the lens is focusing. As an example of one of these, this is a Canon EF 16-35mm f4L IS USM lens. Now, these lenses still have a mechanical connection between the focus ring and the focusing elements. However, it has, due to the way the lens is designed or the autofocus motor, a form of one-way clutch. Basically, motion can be transmitted from the focus ring to the focusing elements inside the lens, but not the other way around. Now, the telltale sign that you are looking for that your lens falls into this category is that the focus ring doesn't move when the autofocus system runs, but you can still focus the lens with the focus ring when the camera is either off or when the lens is completely disconnected from a camera. Now, this one-way transmission setup does create problems for our follow focus because the lens's actual focus position can change without feeding that change back into the focus ring and in turn our follow focus. The most common reason that this will happen is that the autofocus system was activated. However, this can also happen if you manually turn the focus ring past the infinity or minimum focus distance positions. In these cases, the lens elements, of course, in the lens will hit their limits and stop moving. But because the focus ring doesn't have a hard stop, it can continue to turn, getting things out of sync. Now, in both of these cases, the follow focus, with whatever stops or marks you have set on it, will no longer be in sync with the lens's actual focus position, and you will have to manually readdress that problem. Now, addressing the autofocus problem or issue is simple. Just switch your lens into manual focus mode, and the camera won't autofocus it. However, turning the lens past the end focus positions is something you will just have to practice not doing. Now, I said those are mostly the problems, but there is one other setting that can affect these lenses. Many cameras these days have a setting for retracting, extending focusing lenses on power off. This feature works by focusing the lens to its infinity position, and the camera completely ignores the autofocus manual focus switch on the lens when this is set and enabled. Now, in theory, this function should only apply to those lenses that extend when focusing. However, in some cases, it doesn't. Specifically, if you are using a Canon EOS R camera where, either due to a bug or an undocumented design change, the camera will focus every lens to infinity when this is enabled, not just the ones that extend. Now, on EOS R cameras, you'll find the retract lens on power off setting on the custom function for menu page. If you're using an R5C or any of Canon's other cinema cameras, the same setting you're looking for there is just retract lens, and you will find it on page 9 of the system setup menu, or somewhere around there. Now, while these lenses aren't foolproof, making these changes go a long way to making them more compatible with using it with a follow focus and marks and stops. And this brings me to the last kind of lens that I'm covering, the electronically coupled lens. Now, for better or worse, this has become the standard design for mirrorless lenses from pretty much all of the manufacturers out there. However, for a follow focus user, this creates even more problems that we have to deal with. With these lenses, all of the problems I mentioned in the semi-directly coupled lens setting section applies. However, these lenses also won't focus without power when the camera isn't ready, or when the focusing, and the focusing response can often be controlled in software on the camera, so they may behave differently depending on camera settings. Now, addressing the first part of this problem, focusing without power or when the camera is ready, there is no technical workaround here other than making sure you don't touch the follow focus when the camera is off in a menu or in the image review mode. Now, this at least applies to hybrid cameras, standard photo mode ones. On a camera like the EOS R5C, you still have control over focus when it is in a menu. However, variable focus response, or the variable focus response setting can be more challenging to deal with. Now, variable response is incredibly useful for manual focusing, and most brands will allow you to select whether the focus ring either relates directly by position, so how much you rotate it, which is basically the way all lenses have worked until now, or if it changes the focus speed response with the speed that the ring is changing. Now, while focusing based on ring speed is great for manual focusing in general, it should not be used when trying to use a follow focus with stops or marks. Now, on a Canon mirrorless camera, you'll typically find this on the last page of your AF section. You're looking for something called RF Lens Manual Focus, or MF, Focus Ring Sensitivity. On cinema EOS cameras, you're looking for the Focus Ring Response section, and it'll be somewhere in your System Setup section. On the R5C, it's on page 5. Nikon calls this setting Focus Ring Rotation Range, and on the Z8 and Z9, it is Custom Function F9. Now, unlike Canon's setting, Nikon and Panasonic specifically, I know these two at least, it may apply to other brands as well, take this setting a step further and give you several options for what the focus ring's mapped rotation will be. So you can change how many degrees it behaves as. However, remember the follow focus itself is going to gear down the rotation speed to start with. So choosing the ring rotation range will impact both your focusing precision and speed. A larger range will allow you to focus more accurately, but it will also slow down the focusing rate. Likewise, a smaller angle will increase the speed that you can move between any two focus marks, but will reduce the accuracy that you have in doing so. Now, the question here is, what range should you pick if you have the option? And personally, I would recommend starting somewhere around 300 degrees and then adjusting to taste as needed. 300 degrees is approximately the standard focus ring rotation you find on most cinema lenses, so if you're using those or used to those, that will be a good place to start, and it is generally a pretty good range in general. Now, one final note for you Nikon users out there. Since Nikon lenses use the right-hand rule for their focusing ring instead of the industry standard left-hand rule, their focus rings rotate in the opposite direction as basically everything else on the market. As a result, your follow focus knob will rotate in the opposite direction of normal as well. Fortunately, because this is all electronic now, you can correct this by changing the F8 reverse ring for focus custom function on your camera, assuming it has that setting. If you turn that on, your focus ring will turn in the same direction as every other lens on the market, which can help you make a smooth transition, essentially. So, if you are new to follow focuses, hopefully you found some tips here that will help you get one working with your hybrid camera and the lenses you have. I know I personally struggled with this for a while, as most of the videos that people have out there are aimed at basically just using them in a cinema situation with people shooting with cinema lenses. And therefore they don't really talk about any of the camera configuration concerns that we have on a hybrid camera with modern hybrid mirrorless lenses. If you found this useful, let me know by hitting that like button and sharing this. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you aren't already. Finally, if you'd like to support this channel and future content like this, please consider hitting that thanks button if you can, or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.